What up? It's Kettle Hut, and welcome back to another Aleks video. This is part 2 for this week. In the first part, you should have seen this equation on your screen. You should have seen it already. You've been using it. The x1 and y1 come from one of your given points, and they gave you the slope, and you plugged it all in. You changed it to slope-intercept form, and it was just a wonderful thing. Now the difference is they're not going to give you the slope. We had to find that first. If you do stick around to the end of the video, highly recommended. I'm going to show you 2 ways to do this very easily. One of those using Wolfram Alpha, highly recommended, and the other one is using Aleks to its full potential. Aleks will accept any equation that you give it, so why work harder than you have to? So here's our equation, and now the difference is on Aleks, we'll see that towards the end too, so please skip ahead if you want to skip this part. But Aleks will just give you a line on the graph, and you have to determine and read these points. So for us, we're just given these 2 points, and let's go from there. So if you don't remember, you have to use the slope formula, which is rise over run, so y2 minus y1 over x2 minus x1. All right. And just like before, it doesn't matter which one's which, but we call these points x1, y1 and x2, y2. To find slope, we've done it. You just plug these points into this equation. We have done that in the past, so that should be old news. But to do so, again, you have y2 minus y1, so you're going to take your y2, which is -1, so it's going to be, wrong button. You're going to have your -1 minus your y1 value is 7 all over x2 minus x1. x2 is 1, and x1 is -3. So please do remember you have to take the negatives with it. Also remember, I'm using the parentheses, you should too, so that way we can keep track of things a little better. When you just simplify this down, -1 minus 7 is -8. And then 1 minus -3, remember minus a negative changes to a positive. So 1 plus 3 is 4. -8 divided by 4 simplifies down to -2. So our slope is -2. This is the only thing that's different from what you saw is you have to do the slope first. And again, we've used the slope formula before, so this shouldn't be anything nuts. So if we go back to where we were starting with this, y minus y1 equals m times x minus x1. As our point slope form, this is going to be very handy for you to remember later in life as well. Plugging in everything we know, you can use either point. That's important. I feel like I should mention that, but I'm just going to stick with my x1 and y1. I already labeled it x1, y1, so I'm just going to stay with it. The y and the x don't change. My y1 value with parentheses, y1 is 7 equals m. We know what that is. We solved for it. That's -2. And then times x minus x1. Again, the x and the y don't change. The x1 and the y1 come directly from the point up here. And you can use either point, but I'm using the points that were already labeled x1, y1. Some of you might have seen I've already created my first grave mistake because I'm not paying too much attention. My x1 value is actually -3, and I wrote 7. Easy fix, quick, dirty, easy fix. So we change this to leaving the parentheses for obvious reasons. So y minus 7, nothing to do there. That's just going to be y minus 7. The -2 times x minus -3. First, I'm going to simplify this. Minus a negative changes to a positive. So minus a negative, that changes to x plus 3. Then we have to distribute the -2. This is algebra 1. This is all algebra 1. After you plug it in, even plugging it in, all that stuff's algebra 1. The only, actually, so really none of this is new, but it's just good review, I guess. So -2 times x is -2x, and then -2 times the other one, which is -2 times 3 is -6. We then have to simplify this and put the y by itself because we're looking for slope-intercept form. So to do so, we're just going to add 7 to both sides because we want y alone. Generally speaking, on all of these problems, if you get y by itself, it will solve into slope-intercept pretty nicely. So negative 6 plus 7 then is plus 1. And there you go. There is your slope-intercept form given those 2 points. The only difference from before is first you have to do this step over here where you find the slope. Once you find the slope, just plug it in. This should be all the stuff that you've already done earlier in this video. This is the only quote-unquote new thing, and you've done this before. So then here's the next one in your notes if you guys are following along. Again, the more you write these things, the faster you learn them. So slope is y2 minus y1 over x2 minus x1. So plugging these things in, you can label these however you want. In an effort to make things more positive if possible, I'm going to put this as x1, y1. If you worked ahead and you already did it the other way, that is fine. Doesn't matter. So this actually makes things worse for us, but that's fine. It makes it more interesting. So plugging it in, you have m equals your y2 value is negative 7 minus your y1 value is negative 4. And then x2 minus x1 is going to be negative 6 minus, and our x1 value is 3. So in my haste, I've actually done this the exact wrong way, but that's okay. Still works. So negative 7 plus 4 is going to be negative 3. Why is it plus? Because minus and negative changes to positive. On the bottom, you have negative 6 minus 3. It's going to be negative 9. This is exactly what I tried to avoid. But hey, what are you going to do? Sometimes we screw it up. So negative 3 divided by negative 9. The negatives cancel. It's going to be 3 over 9, which reduces to 1/3. And just to show you if you did this the other way, if you labeled these points the other way, some of you might have done that. You would have had negative 4 minus negative 7, which is a positive 3, and then 3 minus negative 6. So 3 plus 6 is 9. So you would have positive 3 over 9, which also reduces to 1/3. So either way you do it, it works out fine. So now we have the slope. You can choose either point that you want to work with. Just to stay consistent, I'm going to stay with what I had and use this point only because I already called it x1, y1, just to avoid confusion. Point slope form, as we saw, is y minus y1 equals m, x minus x1. Plugging everything in, the y doesn't change. The y1 value we know is negative 4 equals our slope we already saw is 1/3. The x value doesn't change. x1, plugging it in, is 3. Now we do have to simplify it. Y minus a negative 4 changes to y plus 4. 1/3 gets distributed to both of these. All right. So 1/3 times x is 1/3 x. 1/3 times negative 3 is going to be negative 1. And then to get y by itself, do the opposite. So the opposite of plus 4 is minus 4. Subtract 4 from both sides, and you get y equals 1/3 x. Negative 1 minus 4 is negative 5. And you can check this answer in a multitude of ways. You can graph this line that we just had and then graph these 2 points and make a line through them, and they should be the exact same thing. And yeah, good to go. More of the same. Slope, y2 minus y1 over x2 minus x1. I'm going to do these a little faster because if you have trouble, you should pause the video and look at the other ones. So x1, y1, x2, y2, it doesn't matter how you label them. As we saw, I labeled them wrong, so I'm just going to label them. When I say wrong, I was trying to get rid of the negatives, and I actually gave myself more negatives. So not really wrong, just more difficult to mess with. So y2 is negative 6, minus y1 is negative 1, all over x2 is 4, minus x1 is 2. -6 minus -1 minus a negative changes to a positive. -6 plus 1, -5. 4 minus 2 is 2. So we got a little bit of a weird slope here for the first time. So using this as our slope then, remember the formula is, and it's point slope form, it's not really a formula, m times x minus x1. Y and x don't change. Y1 comes from our point, which in this case is -1. M is -5/2. X minus x1, so x doesn't change. The x1 value comes from here, x minus 2. Remember, the minus is in the formula, so notice, you might have noticed it's changing. That's why we always do this. And if you want, you can leave these parentheses here too, this set. Y minus y1, y minus -1, excuse me, changes to y plus 1. -5/2 times x is -5/2 x. And then distributing again, -5/2 times -2. The 2's cancel and you're left with plus 5. Negative times a negative gives you a positive. 5/2 times 2. The 2's cancel, you're left with 5. You want y by itself now, the opposite of plus 1, minus 1. And you're left with y equals -5/2 x plus 4. One more to do. Oh, forget to take your pictures. Yep, forgot to do that. -3, -8, and 2, 7. So same thing. You're going to be doing minus. So I want to put, I think labeling these this way will actually be better. So let's just do it this way. You can do it either way you want. Sometimes if you try and think about it, it makes things worse. But so again, slope formula. The more you write it, the more you'll memorize it faster. y2 minus y1, you're going to have 7 minus -8 all over x2 minus x1 is going to be 2 minus -3. Please notice I'm using these parentheses again to let you really see that the minus a negative turns into a positive, minus a negative turns into a positive. Now our first real nice slope of the day, 3. 7 plus 8 is 15, 2 plus 3 is 5. 15 divided by 5 is 3. And then the formula, plugging these things in, using, yeah, it doesn't matter. That's fine. We'll just keep using this like we have been doing. So this -3, -8 will be our x1, y1. It's already labeled that way, might as well. So our y1 is -8 equals, our slope is 3, x minus x1 is -3. Y minus -8, minus a negative changes to a positive, minus a negative changes to a positive, so this is plus 3. Distribute, 3 times x is 3x, 3 times 3 is 9, and then to get y by itself, do the opposite, -8 from both sides, and you get y equals 3x plus 1. This is our slope-intercept form, and it came from 2 given points. So now this is the part of the video that you want to jump ahead to. If I can be bothered, I'll put a timestamp in the description, so that way if you read the description, you can jump straight to this. I don't know why I'm telling you that now. If you're hearing that now, we're already here. So I should have told you that earlier. Can't go back in time. Maybe I'll edit it. No, that takes work. I don't know. We'll see. Okay, so Aleks, here's what these Aleks questions look like. And these will work exactly the same way, because these are the 2 that are going to be from this part. You just have to read the point. So for this one, for example, it would be -6, 5, and the other point is 6, 2. So if you take those 2 points, you can do what we just did and solve it and do all that work, right? Do it and be fine. Now there's 2 ways to cheese this. First way is you really just need the slope. So Aleks is really not picky about what you put into it. So you really, as long as you find the slope, and you can do that by counting. Slope is always rise over run. So if we look on, I went back to this example. So we're going from 0, -2 all the way up to 8, 6. You just need the slope first. So counting slope, counting up, you go 1, 2, 3, 4, 5, 6, 7, 8. So our rise is 8. And our run is 1, 2, 3, 4, 5, 6, 7, 8. That is a slope of 8 over 8 reduces to, really nicely, 1. So we have a slope of 1. This is our m value. If you plug these into our slope formula, you'll get 1. You can just count it. That's even easier. I'm trying to show you the nice way to do this. So the slope is 1. Just remember that. We also remember our slope, point slope form is boop, 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 right here. So our point slope form is y minus y1 equals m times x minus x1. We know m, which is just 1. Right? So as long as we can find an x1 and a y1, we're good to go. That's all we need to type in. And for these Aleks problems, when they're giving you the point like this, it's just choose one of the points. So the one that's nicer to work with is 0, -2, smaller numbers. So the formula is y minus y1. So what's the y value of this first point? -2. Right? Using the parentheses equals, and then you have m times m, which you said is 1, times x minus x1, which in this case is 0. I think Aleks will take this. Just to be sure, you should probably double check. You should change this to y plus 2. Let's actually see if Aleks will take this. I'm fairly certain it won't. Oh, yeah, see? It can be written where some parentheses aren't used. So if you change that to, even if you just leave it this way, or if you change this to y plus 2, it'll be fine. You can see what it really wants is slope-intercept form. That's what we tried to do in the notes. It's fine this way. It'll take it. The other way to do this is if you don't want to count the slope. So if you were to count the slope here, it'd be down 1, 2, 3. So your slope would be -3, and then your run is how far over does it go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I believe you don't even have to simplify that. So let's put this in. You're going to have y minus y1, which you can choose either point. So let's choose this one here on the right hand side of the screen, 6, 2. So y minus 2 equals, our slope is -3/12. You should probably simplify that, but let's see if Aleks will take it without it. Times x minus x1. The x1 value is 6. I don't know if it'll like this one because that's pretty, oh, see, there you go. Jeez. If this confuses you, there's one more way to do it. Our friend, probably as good, or if not better than Desmos, is Wolfram Alpha. Please, 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 Wolfram Alpha. It's amazing. So to do Wolfram Alpha, this is, you just have to type this in for this, line through, and then type in your points. So let's get another example just to do real quick. Try another. So as long as you can read these 2 points, that's all you need to do for Wolfram Alpha. So this one is going to be -2, -3, -2, -3, and I'm just typing this straight in. Close the parentheses for the space, open them, and then type the other point in. 4, 1, 4, 1. Close the parentheses, hit enter. It'll show you the line. You should double check that it looks the same. Look, that looks the same as that. Yep, sure does. So there's your slopes and your intercepts and all your stuff, right? So for us, you would just take any one of these and type it in. I would recommend slope-intercept form because that's what Aleks is specifically probably looking for. However, for giggles, and this may not work because I had not tried this, but I wonder if you can just type in the standard form. So if you just type in the standard form, that's the easiest one to do. 3y minus 2x equals -5. Shouldn't use capital letters. That's bad taste. Sorry, caps lock. And 3y So then I'm just typing in the standard form just to try it. You should do slope-intercept form, but it's a little bit harder. But right, so it even took that. So there you go. Wolfram Alpha will literally do it for you. That's the last stitch effort. But if you made it through this far in the video, you deserve it. If not, skip ahead in all the other videos. We try to do that for you. So yeah, we'll see you on the next one.